All right, we're going to bring out our first guest. This gentleman is a biologist from the wonderful Georgia Institute of Technology. And so let's have a hand and please welcome to the stage Dr. WilliamRatcliff.
Hey.
Hey, Will. Great. Thank you for coming.
Thanks for having me.
Yeah.
This is great.
Will, tell us a little bit. You're kind of a. You look like a multicellular person. You look like you're more than one cell.
Last I checked.
I'm just going to say that. I'm coming up from the front. So, Will, tell us a little bit about what your interests are scientifically, just to get started.
So in general, I'm interested in understanding how complexity arises in evolution. I'm an evolutionary biologist. And I'm really sad to hear that your basement experiment with time travel isn't really working out so well.
Out fine.
It's working out.
You're willing to go
okay.
1 second per second. I don't know what you're talking about. That's how I got here.
So my interests lie a little bit in the past.
Yeah, in the past.
Because I'd like to understand how the complex life that we see around us arose in evolution, right? If you think of sort of a natural scene, right? You imagine a beautiful tropical rainforest, right? And you sort of close your eyes. Do you have any, can you guys do New Age? Maybe we could play some New Age music.
Does Lucy and Simper look like they can do New Age?
Or something very calming,
Rainforest music.
Yes.
Oh, Pete, you missed Copernicus.
Yoga at the same time.
Sure. All right, so imagine a beautiful rainforest, right? Now, take away the plants, the ferns, the trees, the bryophytes, the shrubs.
There's not much left.
Right? Maybe you hear a rain of insects as they fall because there are many hundreds of thousands of species of
Birds
insects.
too, I'm thinking.
Birds, flapping of birds, things falling on your head from the birds. Those are animals. Get rid of those. They're multicellular. What do you have left? Maybe some
Lou is what I'm thinking. It's he's that far down on the chain.
So you're calling him a mushroom. All right, well, mushrooms are also multicellular, so we can get rid of those.
No
and basically, if you remove...
Bacteria.
There are multicellular bacteria, but you can't generally see them very well with the naked eye. And then my point is, what we think of as life is characterized, at least at the visual scale, by things that are multicellular, right? If you remove all multicellular organisms from planet Earth, you're left with maybe a sort of a greener version of Mars.
So yeast.
So I work with yeast, and because we can't travel back in time, back between really 1.1 and 600 million years ago, when most of Earth's major lineages of multicellular organisms sort of made their first foray into multicellularity, because we can't go back in time and understand how the single-celled ancestor of those lineages made those first steps to multicellularity, we're doing that in our lab. And we use a technique called experimental evolution, which is sort of like crop breeding. We basically are doing selective breeding experiments.
So you can do evolution in your lab?
That's right. We do thousands
but
of generations of evolution.
But not in Cobb County, right?
Right, I'm a little concerned about that one.
So, I mean, so that's awesome that you're actually able to evolve in your lab.
That's right.
And what kinds of, have you made yeast that can fly?
No, but we haven't been selecting for flight. In fact, if you were to do the experiments in my lab, I'd probably kick you out.
Oh, I see.
Because it would involve throwing around yeast in my lab, which is not so cool.
Eventually, it's got to learn to fly. You got to kick the yeast out of it.
Maybe DARPA will be interested.
All over the place.
So tell us a little bit. I mean, for example, you work with both flocculating yeast, which is just fun to say.
Gesundheit.
Flocculating yeast and snowflake yeast.
It sounds like a safe curse word.
Yes.
Like, flocculating.
The newest thing on I-75.
Actually, so flocculating yeast are yeast that are, many yeast in nature are sticky. They adhere together and they form these blobs, which is sort of what we might call a biofilm. And I-7585 is a fantastic example of cohesion, of things coming together and forming a group, and which is generally annoying for us.
So yeast, flocculating yeast, or snowflake yeast, which one makes better beer?
You knew that was coming.
I did know it was coming.
We knew that was coming.
Now, okay, I should explain what snowflake yeast are. Snowflake yeast are what we evolve in our lab. If we take a single-celled ancestor and we select for size, we get these very nice geometrically ordered multicellular groups, which over thousands of generations of experimental evolution get a multicellular life cycle such that groups produce new little baby groups, and those baby groups have to grow to their parent size before they reproduce, make their own baby groups. We've even seen a simple form of cellular division of labor arising, where some cells in the group, they're all genetically identical in the group, evolve to kill themselves in a way that is for the good of the group. And so we are basically getting bona fide, yet simple multicellularity evolving. And these guys are much better in our experiments than flocculating yeast, these yeasts that stick together and form these.
So you're kind of like playing God with yeast.
Kind of, yeah.
So in your
Yeah,
lab,
yeah.
you're recreating this transition from single-celled going toward multi-cell.
Exactly.
Okay. Does anyone knock on the door from Cobb County and say, "What are you doing in there?"
That can't be!
They have not yet, although we did host a AAAS symposium group that visited our lab that was 50% scientists, 50% clergy.
Really? So
Yeah.
do you ever have to face evolution deniers and people who are, maybe...
Yeah, all the time.
How do you bring them to your lab and give them yeast?
I would love to. I would love to. If you're an evolution denier and you want to come to my lab and get yeast, I'd be happy to do that. So we do. I think in general, you don't want to be a jerk, right? Sort of rule one is don't be an ass.
In general, okay.
Yes, except for
It's
the
a good
host
life.
of this
This is
show.
a good life lesson, but also good for science, because it's a contentious issue and people have very, very strong feelings about it. And so my goal as a scientist is to essentially explain what we're doing without pressing buttons.
I see.
And one of the nice things about our research is that rather than having to sort of rely on somebody essentially putting their faith in you, that you're telling the truth, that yes, these things did evolve from common ancestors and all life that we see on planet Earth descends from a single common ancestor, and we have very good reasons for thinking that. But you have to think through those reasons to really explain it to someone. In our lab, I can show you, here's the actual ancestor, here are things that I evolved, right? You can't really deny that because it happened over a very short period of time, chronologically, even though that was thousands of generations from the perspective of the yeast.
Excellent. All right, so let's give a hand to Will Ratcliff, evolutionary biologist, and let's make a little room on the couch for our next guest.